Hi everyone, welcome back to our series. Hope you're doing good. This is Mahesh. In this video, we will look into LeetCode problem number 724, which is find pivot index. Okay, let us look into the statement of the problem. So, given an array of integers, nums, calculate the pivot index of this array. Okay, what exactly is a pivot index? Let us see. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right side. Okay, so if the index is on the left edge of the array, then the left sum is 0 because there are no elements to the left, and this also applies to the right edge of the array. Okay, so return the leftmost pivot index. If no such index exists, then return -1. Okay, they have given few examples and they have also given the constraint. So the length of nums ranges between 1 and 10 raised to 4. Okay, and the value in the nums array ranges between -1000 to +1000. Okay, with that, let us switch to our editor and let us try to understand the problem. Okay, so with that, so they have given this particular nums array. Okay, so now if you see, if you stand at this particular number and if you sum up the left elements, which is 1 plus 7 plus 3, it is 11. Correct, right? Now if you see the right side elements, you need to leave this number because you are looking at left and right from this particular number. So you need to leave that number. Now if you see 5 plus 6, which is 11. So now if you see, this left side value is equivalent to this right side sum. Correct, right? So this is called prefix sum, this is called suffix sum. So we have successfully introduced the concept of prefix sum in our previous video. So if you have not watched that video, please go back and watch that video because we are going to use the same concept in this video. I will leave the link in the description. So with that, so now for this 6, basically 3 is its index, so we need to return 3 here. Okay, so we have also seen the constraints for this problem. With that, maybe what you can do, you can pause the video, you can think for possible solution, and then you come back and watch this video. With that, now how to solve this problem? What is the brute force for this problem? Basically, if you see, when I stand at a number, what I will do, I will iterate over all the numbers towards its left and I will find the left sum, which is prefix sum. Okay, then I will iterate over all the right side numbers and I will find the suffix sum. Okay, then I will check if they match. Then what I will do, I found my pivot index and I will return that index. Okay, so let us look into that. So now what I will do, I will start from first number. So they have also given, right, if you are standing at the first number, there is nothing on the left side, right? So assume left will be 0. Okay, in case if you stand at the last number, then you need to assume the right value as 0. So now my left value is 0 initially, my right value will also be 0 initially. Okay, so since we are standing at this number, if you leave this number and if you look at left, so there is nothing, so I will keep the left value as 0. But if you see, there are so many numbers towards its right, so what I will do, I will sum up all the numbers. I will sum up all the numbers. So if you sum up 10, 16, 21 and 27. So our right sum will be, so suffix sum will be 27. Now if you see, our prefix sum is 10, our suffix sum is 27. They are not equal. So this is not our pivot index. So now what I will do, I will move to the next number. Okay, now if I move to next number, my prefix sum will be the sum of only one number, so which is going to be 1 here. So it is going to be only 1. Now my suffix sum is going to be sum of all these numbers. So which is going to be 3 plus 6, 9, then 14, then 20. So 20. If you see, my left value or prefix sum and suffix sum is not equal. So what I will do, this is not my pivot index. So I will move to the next number. Now if you see, our prefix sum will be 1 plus 7, which is 8. So our left value will be 8. Okay. Now if you see the suffix sum, it is 6 plus 5 plus 6, which is 17. So I will update my right value as 17. So they are not equal. So it means this is not our intended number. Now I will move to the next number. Now if you see, this is our prefix sum, this is our suffix sum. So now if you sum up the prefix sum, it is going to be 1 plus 7 plus 3, which is 11, and the suffix sum is 5 plus 6, which is 11 again. So now if you see, our left side sum and the right side sum are same, which is 11. So if that is the case, then this is our intended pivot index. Okay, then we need to return our index value, which is 3. Okay, so this is how we need to find. So in case if there is no pivot index exists, then what happens? We will keep on moving this pointer next, this pointer next, and it will move out of the index. So if that is the case, then we don't find the pivot index. We will have to return -1 in that case. Okay. So with that, let us try to write the pseudocode. So for writing the pseudocode, what we did, we took one array which iterates over each number, correct, right? So I will call that as first, I will take it as first array. So for I equal to 0, I basically till n minus 1. So this is my first array. After that, I need two variables, right, to find my left value, basically the prefix sum and the suffix sum. So I need these two variables. So basically what I will take left equal to 0 and right equal to 0. Then what I will do, I will have to iterate. So if I am standing at this point, at this number, I will have to iterate from 0 till one index less than this particular number's index, correct, right? So now what I will do, I will take another loop for j equal to 0 till j is equivalent to I minus 1. I need to iterate. Okay. So this gives me the left sum. So I will say left equal to left plus nums of j. Okay. Then what I need to do, I need to take one more array. Sorry, I need to take one more for loop. So which starts from basically one value after, if I am checking for this particular value, then it should start from here, right? One index after that. So basically I will take k equal to I plus 1 till n minus 1. Okay. Then I will say right equal to right plus nums of k. Okay. Then finally, after end of the second for loop, what I will do, I will check if my left value is equivalent to my right value, then I found my pivot index. So I will simply return my index I. Okay. So this is how we need to do. If that is not the case, at the end of the for loop, we will have to simply return -1. This is when we don't find any pivot index. Okay. So now if this is the case, what is the time complexity for this one? So basically this is one for loop which runs from 0 to n minus. Again inside we use two for loops, right? So is it order of n cube? No, because it runs only half of the array, then this runs for the remaining half of the array. So if that is the case, it is one full iteration. So for each number, this is going to be almost order of n. So our time complexity will be order of n square. Okay, so do we use anything extra here for the space complexity? No, right? I mean, we are not using anything extra apart from this left and right, these variables. So it means it is of order 1. Okay, so this is basically our time complexity and space complexity. Now if you see, our time complexity is of order n square. So this is where the interviewer will not be happy with. So what we need to do, we need to improvise this. So if we want to improvise this, then we might need to bring it down from order of n square to order of n. Okay, so how to do that? Let us see. Now, if you see, I have taken the array again. So this is the array. Now I will use the concept of prefix sum. Okay, so basically if you have seen the previous video, which is running sum, now what I will do, I will find the running sum of this particular array. So running sum is basically, if you stand at any number, then you need to sum up from the value at the 0th index till that value, then all the added number will give us the running sum of that particular number. So if that is the case, let us see what will be the running sum. For 1, there is nothing before, so it is only 1. So for 7, it is going to be 1 plus 7. So it is going to be 8. For again here at this particular point, so it is going to be the sum of all the 3 numbers. Now if you stand at this particular number, it is sum of all these numbers. So likewise, this is going to be 1, then 1 plus 7, it is going to be 8, then 1 plus 7 plus 3, it is going to be 11, then 1 plus 7 plus 3 plus 6, it is going to be 17, then 22, then 28. Okay, so this is our running sum, correct, right? So this is the first step. Why we are doing this? Let us see. So now, one thing what we know, if we stand at any number, this is the left sum, which is called prefix sum, that we have already seen, right? So now if you want to stand at this particular number, this is our prefix sum, correct, right? So this running sum array will give us the prefix sum for this particular number. It means we already have calculated the left sum. Okay, so if that is the case, we know here this is the left sum for this particular number, correct, right? So the other concept would be, this is the running sum of this particular number, right? So what is the right number then? So do we really need to calculate the sum of the right side numbers? No, right? Because this is the sum of all the numbers, correct? And if I stand at here, so if I want only sum of these two numbers, I need to remove this much sum, correct, right? So that is nothing but 17. So if you remove 17 from this 28, then you will get the right sum. So this is the basic intuition, I mean, for solving this particular problem. So now what I will do, if I stand at this number, its prefix sum will be my left. So basically, if I stand here, this is its prefix sum. So I will take left as 11, correct, right? Now what I will do, for right, I will simply say overall sum and sum till this number, basically this value. Okay, so we easily get that as 28 minus 17, so 11. Now we easily got left and right, correct, right? So with this, if left is equivalent to right, then this is our pivot index, correct, right? So now what we will do, let us try to derive this particular formula. So first we found running sum. So this is first step. Step 1 is find running sum. Okay. So after that, you stand at any number, then you find the left and right. So left will be this particular array with one index less. So if I am standing here, then I need to take this number. So left will be, if I consider this as prefix sum array, then it is going to be prefix sum of I minus 1, correct, right? Then what is right? Right will be prefix sum of n minus 1, basically this last number, then prefix sum of that particular number only, because this gives the running sum of this particular number, correct, right? So it is going to be minus prefix sum of I. So this is our right value. So now I will compare whether this left and right values are same or no. Then what I will do, I will return based on that. So let us quickly look into its dry run, or we have already seen, but just for understanding, let us see. Now assume I am standing at 1. Okay. So if I stand at 1, then my left will be, basically I'll take left will be 0, because I'm standing at the first number and there is nothing before that. Then my right will be basically this value, which is 28 minus then this value, correct, right? So it will be 1. So it is 27. So 0 and 27 are not same. Now what I will do, I will move to basically next number. So this is first number I finished, I move to next number. Now my left will be 1, correct, right? So left will be 1 and my right will be 28 minus 8, because we need to consider the current values prefix. Basically the running sum of the current value. That's why it is 28 minus 8. Okay. So it is going to be 20. Again, it is not equal. So it is not the pivot index. I will go to next number. Now if you see, its prefix sum is 8, correct, right? So what I will do, I will take my left as its prefix sum, which is 8. Now our right will be 28 minus 11. So I will do 28 minus 11, which is going to be 17. So this and this values are not equal. So this is not our pivot. Now if you see, when I'm at 6, so my prefix sum will be 11, correct, right? Then this is going to be 28 minus 17, which is going to be 11. Now if you see, we found our pivot index, then we will have to simply return that index. With that, let us look into the pseudocode. So basically what we did, first we found the prefix sum. So I will take prefix sum is of size, is an array of size n. Okay, this is our prefix sum. Then what I will say, prefix sum of 0 equal to nums of 0. Basically we are trying to find the running sum. Okay, then what I will do, for I equal to 1, because already I have processed 0 index till n minus 1, what I will do, I will say prefix sum of basically I is equivalent to prefix sum of I minus 1 plus nums of n. Okay, so this gives us the running sum at index I. Okay, so this array will compute as the running sum. So now I will take two variables, left equal to 0, this is basically the prefix sum, then right, which is equal to 0, which is the suffix sum. Now I need to compute the left and right sum for each value. So I will take again a loop. So I equal to 0 till n minus 1. So I will check if my I is greater than 0, then only I can take the left value from the prefix sum array, right? So if I is greater than 0, then I will say my left will be prefix sum of I minus 1. So this will give us the prefix sum. Okay. Then we need to find the right value now. So after this, what I will do, I will say our right value is basically prefix sum of n minus 1, basically the last value, minus prefix sum of the current index. So this will give us the right value. Now I will check if my left and right are equal. Immediately after that, I will simply return I. If that is not the case, finally at the end, what I will do, I will simply return minus 1 because we never find the pivot index. Now if you see what is the time complexity, here basically it is of order n to find the prefix sum, correct, right? So this is order n. Then we again iterate over the entire array and we will check, we will find the left and right values, basically prefix and suffix values. Then we will check whether those values are equal or not. So basically here also it iterates for n times. So order of n. So this is order of n. The above thing is order of n. So basically time complexity will be order of 2n. So you can say order of n. Okay. So this is a two-pass solution. What about the space complexity? So we use this prefix sum array, right? So that is of order n space complexity because we use that extra space to store the prefix sum. So with this, let us execute this and see. So let us take a variable n equal to nums dot length. Okay, this gives us length of nums array. Then let us take a integer array which is prefix sum new int of size n. Okay. Then what we will do, we will say prefix sum of 0 equal to nums of 0. Okay. Then what we will do, we will process the array. So int I equal to 1, we will start with 1 because we have already processed 0th index. I less than n, I plus plus. Okay. Now what I will do, I will say prefix sum of I is equivalent to prefix sum of I minus 1 plus nums of I. So this will give us the prefix sum. Basically this is the running sum, but we use the prefix sum concept here. So running sum of the array. Now once after this, now what I need left sum which is initially 0, then I need right sum which is also initially be 0. Then after this I will use for loop int I equal to 0. Now I will start from 0, I less than n, I plus plus. Okay. Now what I need to do, I need to find my right value and left values, right? So I will first check if my I is greater than 0, then only I will update my left value with prefix sum of I minus 1. Why? Because if it is 0, then there won't be anything in the prefix sum, right? And it goes out of the array, so that will throw an error. And also we should consider left as 0 in that case. Then what I need to do, I need to find my right value. So right value will be prefix sum of n minus 1, okay, minus prefix sum of I. So this will give us the right sum, so basically suffix sum. Now what I will do, I will check if my left is equivalent to my right, then I found my pivot, so I will simply return this index because we found the pivot. Okay, so finally, if that is not the case, we will have to return minus 1. Okay, so with this modification, let us try to run and see. Okay, I missed semicolon, which I do oftenly because of my JavaScript habit. It got accepted and I will submit it. So this got submitted successfully. Now, is there any way to improve this? Because we have already solved it in order of n time complexity, right? So maybe yes, because it uses extra space here. So we need to improve this one. So how to remove this extra space? So if we need to remove this extra space, then we need to remove this prefix sum array. So how to do that? So maybe what I will do, I will copy this. So if you take this array, the left sum or the prefix sum, we can compute it while we iterate over the array, correct, right? How? When I am here, I will take this value as the prefix sum. When I move from here to here, for this prefix sum, I'll add this value before moving. So this gets updated with 8. So at this point, when I am processing this value, I will have my prefix sum as 8. So on the go, I can simply find my prefix sum. So this gives us one value, the left value, correct, right? So if that is the case, how to find the right value? Let us see. That is very interesting here. So assume you are standing exactly here. So this is our pivot. We know this. That's why I'm trying to take this point. Now, if I know this left sum, it is it is while processing the array. So this is our prefix sum. Then we can find the right sum. How? What we know. So if this is our left part, this is our number, this is our right part. So if we know the total, assume this is our total value. Total means sum of all the numbers, correct, right? So it is left plus number plus right value. This will give us total. Now I know this one, I know this one, I know this number where I am trying to process the number. So if I am standing here, I know the prefix sum, this is left, I know the number, this is number, and I will have to calculate total. So I will calculate it earlier. So I can simply find the right, correct, right? So our right will be total minus left minus the current processing number, correct, right? So this will give us our right. So if left and right are equal, again we will use the same logic. We will simply return that as a pivot index. So now let us see. First find the total. So total will be 28. So in one iteration, I will find my total value. Okay. So this is my total. Now I will start processing this array. So I will start from this number. So I will take prefix sum. It is not an array now. It is only a single value. So it is going to be 0 initially. Okay. So if I want to process first number, its prefix sum will be 0, correct, right? Now what I will do, I will try to find my right. So right will be total is 28 minus left is current prefix sum which is 0, then minus the current number which is 1. This is the number we are processing. So what I will do, I will say this one. This is our right value. So instead of prefix, I will say it as left only, so that we can easily understand. So now if you see, our left is 0, our right is 27. They are not equal, right? So now what I will do, I will simply update my left value because I need to move to the next number. So I will simply add 1 to it. So it becomes 1. Then I will move to next number. Now I am at 7. Now if you see, this values will change now. My total is still 28. Then my left value is 1 and the current value is 7. So now if you see, we get 20. So left and right are not same. So what I will do, I will add 7 to it. So it becomes 8 now. Okay. Then I will move to next number which is 3. So now if I am at 3, then I will subtract this 8 from 28, then the current number 3. So it is 17. Now if you see, 8 and 17 are not equal. Now what I will do, I will add this number here, 8 plus 3, it is equal to 11. Okay. Then I will move to next number. Now I am at 6. Okay. So now if you see, 28 minus left is our 11. Then current number is 6. What is the answer? It is 11. Now if you see, left and right are same, correct, right? So this is our pivot index. So this is very simple and straightforward. So this is how we need to optimally find the pivot index. So with that, let us try to write the pseudocode for this. So now what I will do, I will take a variable total. Okay, initially it will be 0. Then I will use for loop I equal to 0 till n minus 1. I will say total equal to total plus nums of I. Correct, right? So this will give us total. Once this is done, then what we need to do, I will take left equal to 0 initially. Okay. Then what I will do, I will process the array for I equal to 0 till n minus 1. Now I will find right equal to total minus our left value minus our current value, nums of I. Then after this, immediately I will check if my left is equivalent to right, then we found the pivot, I will simply return I. If this is not the case, at the end I will simply return -1, which indicates we did not find the pivot number. Okay. So now if you see the time complexity, we are using this iteration to find the total, correct, right? It is of order n. Okay. Then we use this second iteration and we try to find the right number. So this is again order of n. So if you see, the time complexity is of order 2n. So somewhere we can call it as order of n time complexity. Now if you see the space complexity, we are not using anything extra, right? So this is the main improvement we did. So that's why it is optimal and it is of constant space complexity. So with that, let us execute this solution and see. Now what I will do, I will remove this part. So I need a variable total which will be initially 0. Okay. Then this value should start from 0. Then this should be total equal to total plus nums of I. So this will find us the total value. Next, after that, we need the left value. Let us also remove the int value from here. Then what we can do, we can remove this part. I will say int right equal to total minus left minus nums of I. Then immediately after that, I will check if my left value is equivalent to my right value. If that is the case, I found the pivot and I will return from here. If that is not the case, I need to update my prefix sum, which is left. So that is equal to left plus equal to nums of I. So I need to add the current number before going to next number. Then with this modification, we are good. Let me try to run it and see. This got accepted. I will submit it. If you see, our solution got submitted successfully. So with that, hopefully, you liked the explanation. This is the way, like, we use the concept which we learned in the previous video, which was a prefix sum concept, and we applied that concept here in this video and we solved this problem. Okay, hope you liked this explanation. If that is the case, please consider subscribing to my channel and also like the video, share this with your friends, and also add your comment saying you understood this well. Thanks for watching the video.